Welcome to this session. In this session, we will try to understand everything, all features of IPv6. We have seen IPv4 till now. What are the benefits of IPv4 and what all are feature it has? But in this session, we will try to understand IPv6 features. So before that, let's try to understand why we need IPv6. So we have seen that IPv4 gives us around 4.3 billion addresses, but we have around 15 billion devices, and making 15 billion devices to connect internet with the help of 4.3 billion addresses is difficult. So that's why IETF, in Internet Engineering Task Force, came up with NAT and private IPv4 ranges. But the thing is, this solution is still the patchy solution, right? It's a it's not a permanent solution. It's a patchy solution. They have applied it as a patch. But parallelly, they were working on another permanent solution, and that is IPv6. So IPv6 doesn't need NAT, CNAT. It doesn't need it. And what kind of devices you use? What are the types of devices like IoT devices, cloud containers, cloud servers, VMs, and all these devices are keep on coming, right, as the technology evolved. And for all these devices we have a sufficient IPv6 range. So that much big range IPv6 has. So it has around, IPv6 is around 128 bit address. So 2 raised to power 128, that many number of IPv6 addresses we are having, and that is very huge. It's a massive address space. So this is the first feature of IPv6, that it has a massive address space. So even if we evolve with respect to technology, with bringing lot of smart glasses, smart watch, all these devices, we are still have enough IPv6 addresses. We will never fall short of IPv6 addresses. So 2 raised to power 128, around 340 on decillion. This is very big term. So just to give you perspective, we have 4.3 billion IPv4 addresses, right? This undecillion is this much, is every human on the earth, right? We can give him billions of address with IPv6. That much big is this range. So with when we move to IPv6, every person can have billions of addresses. Still, we will not fall short of IPv6 address. That much massive address list it has. So with IPv6, there is no address exhaustion, no need of NAT, and every device can get a globally unique IP. So the IPv6 is second feature is no NAT. In IPv4, we have seen we have a device here. That device goes through NAT. It is present in router. Then again next hop there is another NAT. There's a next hop, there is another NAT, and somehow it connects to internet. But in this is for IPv4. For IPv6 device, he can directly connect to internet. Doesn't need intermediary. It can directly connect to internet, and internet can respond to the device. So it's very faster, no NAT, better your VoIP video streaming because it's a faster, right? So all these features are present in IPv6. Third feature of IPv6 is SLAAC, that is stateless address auto configuration. So we have seen that when in IPv4, when the device connects to internet, right? So it fires a DHCP request to get the IP, right? DHCP request, it will reach to your router which hosts the DHCP server, and it will return the IPv4 address, and that's how your system gets the IPv4 address. But in IPv6 it's completely different. So in IPv6, as soon as you turn on the system and if your router is turned on, the router itself advertises that I am the one who provides the internet. This is my network prefix and this is the gateway. Router will advertises this and the device learns from this on its own and generates its own IP. So generation of IPv6 address happens at device, not at a router level, right? So your device is capable of generating own IPv6 address. That's why the device will generate global IPv6, then link local IPv6 address and temporary IPv6 address. All these addresses device generates on its own. DHCP v6. This is exists, but this is optional. It's not mandatory. So this is one of the feature of IPv6. Now next feature is, which is the fourth feature, is link local address. We have seen right now that as soon as the device connects to internet, it will generate a link local address. We have seen that, and that you can verify in IP config. So what is the purpose of this link local IPv6 address? Because it is another IPv6 address assigned to your system. So it is used for neighbor discovery, router discovery, and LAN communication. If you want to communicate within LAN, then you can use it. And the beauty is it even work without internet. So you don't need internet to communicate in LAN. You can directly communicate with IPv6. So that is the beauty of IPv6. Next feature is broadcast. No broadcast. This is the feature of IPv6. IPv6 only has multicast and anycast. Multicast and anycast. So what does this mean? So initially what used to happen is in IPv4 support broadcast. So you would have seen, right, 192.168.10.255. If you want to send some message to all the devices in the network, then you send the message to this IP address and it will be forwarded to all devices. That is called as the broadcast. Now some of the devices might don't want it, but still they will receive the message. They need to read that message, their OS has to process that message, and all this unnecessary stuff, still the device has to do it even if it doesn't need that message. But in IPv6 we are targeting to the only interested people. That's why we have a multicast. So how multicast work is, there will be a group form where the subscribe individuals only will join. Those who wants to receive the particular message, those guys only will join, And multicast addresses will be something start with FF02 in IPv6. So when you want to multicast using IPv6, you send it to this range, and all the subscribed individuals only will get that message. The unsubscribed one will not get it. So this causes better performance, less noise, and cleaner network. Okay. And what about anycast? Now anycast is another feature. So what happens in anycast is, if you want to send the message to the server or only router, you don't want to send it to all the devices, then anycast address will help. So anycast also will have a address range like this, and if you send it to that, then only that message will receive to router or server nearby. So that is anycast. Next feature of IPv6 is, which is a sixth feature, is simplified header. So IPv4 header we have seen, it's a very complicated header, right? So in IPv6 the header is fixed at 40 bytes. So this is the comparison of IPv4 versus IPv6. So you can see that IPv6 header is more simplified one, and it is with less bytes also. So this simplicity of header is important, and it is a better efficient, you can say. Now the next feature of IPv6 is built-in security, which is the seventh feature, built-in security. So IPv6 comes with IPsec, that is IPsec support, and this is built in. If you are using IPv6, then you will get this IP security support. So what is this IPsec security? So it supports authentication, then encryption, then data integrity. All these things are supported in IPv6 by default, since it is coming with IPsec. So this makes secure networking easier. So that is the beauty of IPv6. Another feature of IPv6, which is quality of service, better quality of service, better quality of service. So in the header of IPv6, we have seen we have a traffic class, flow label, right? This helps IPv6 for voice traffic, video traffic, and real-time apps. So this makes it very useful for VoIP kind of streaming, then online gaming. All these things are very much simplified, and they their quality is improved with IPv6. Now another feature of IPv6, which is the ninth feature, which is extension headers. So for this we need to more understand about headers, but in simplified version, so IPv6 has a extension header block in its main header, means in its packet. So if any future, in the future enhancement, technological evolution happens, right? Then this extension header will be used. The existing headers will not be polluted. That provision is made in IPv6. That is there in IPv4 also, but it is limited. But extension header is a large chunk of block available for future evolution. Next feature is IPv6 is designed for future. It's a future proof. So what does this means is, if we have a millions of sensors, because IoT introduced sensors, so even if we have a millions of sensors, we have a lot of cloud native apps, we have a lot of Kubernetes pods, we have a lot of 5G mobiles or network, all these things will be supported with IPv6. We will never fall short of any addresses. So that stuff we don't need to worry in IPv6. So these are the 10 features of IPv6. So that's all I wanted to cover in this session. If you like this video, do share, subscribe and tell your friends about my channel. So thank you.